Hello, this video describes Perfume, an online tool for inferring and visualizing concise models that describe system behavior. Perfume constrains its models based on the system's resource usage. Perfume helps developers understand and debug systems and is applicable to a broad range of resources like memory usage or network traffic. Perfume is open source and can be used in an online deployment at perfume.cs.umass.edu. Today I will use a simple cloud-based music player called DJQ to illustrate how Perfume works. DJQ loads a static playlist and allows the user to perform only two actions: play or pause. When the user presses play, or when the current song finishes, DJQ downloads the next song and plays it. When the user presses pause, DJQ stores the currently playing song on the local file system so it can be quickly unpaused later. Usually, unpausing starts the music right away. However, several users have reported that sometimes hitting play after pausing causes a long wait before the song starts playing. Jenna, a DJQ developer, wants to debug and fix a bad behavior. She starts by looking at the execution logs collected from users, which include executed actions with timestamps. While the logs contain useful information, inspecting them manually is difficult. Can you spot the bug? Good luck. A better way is to use Perfume. Perfume parses a log of executions using regular expressions to infer a precise, resource-aware model of the system behavior. To get started, Jenna pastes in the DJQ logs and clicks Infer Model. Perfume consists of three panels: the log, a behavioral model of DJQ, and a set of temporal invariants. Let's look at the model first. This model describes the system-wide behavior of DJQ by concisely summarizing all logged executions. Each path through the model, starting at the initial state and ending at the terminal state, represents an execution of DJQ, either one from the log or one Perfume predicted. Edges are labeled with an executed action, such as play song, and the time to execute that action, in this case between 4.7 and 8.2 seconds. As the bug is related to slow executions, Jenna starts by looking at the longest execution path. Perfume displays some paths differently based on their performance. For example, the longest path, here the path that takes the longest amount of time to complete, is marked with red. While traversing the longest path, you see a play song action that takes noticeably longer than usual. This action takes as much time as the initial play song action, while all others take less time. This is suspicious. Play song actions after the first one should be fast, since the song should already be cached locally. This suggests a hypothesis. A bug is sometimes causing DJQ not to store a paused song on the local file system. Jenna decides to check if any executions have a pause song action that was not followed by a store-to-file system action. This would slow down play song because the song would need to be re-downloaded. Perfume displays four kinds of invariants that were true in every logged execution, including whenever one action type always precedes, always follows, or never follows a second action type. Here, every pause song action was followed by a send-to-file system action, disproving Jenna's hypothesis. Every time the user paused, DJQ cached the song locally. Jenna notices that some executions are not relevant to the bug because they never play the song after pausing. She would like to better focus on the bug by hiding those executions. A Perfume user can interact with the model by clicking on an edge, which highlights log lines relevant to that execution path. Jenna clicks an edge from a path that does not include a play song action after a pause song action. She removes the executions containing these log lines by clicking Remove Traces with Highlighted Lines. The log is updated with the remaining executions, and both the model and invariants are inferred again. Inspecting this new model that only contains behavior relevant to the bug, Jenna has a new hypothesis. Something must be causing the slow play song actions to re-download the song from the cloud. Jenna re-examines the slow play song actions and notices the slow ones are preceded by a very short send-to-file system, while the fast play song actions have a much longer send-to-file system. Maybe, if the user pauses a song and then hits play too quickly, the file system doesn't have enough time to cache the song, and DJQ mistakenly re-downloads the whole song. Armed with a possible explanation, Jenna runs DJQ several times to try to reproduce the bug, and observes that playing the song is only slow when she hits play very quickly after pausing. She nailed the cause of the bug. After fixing the bug, Jenna receives new logs from DJQ users. To confirm that the bug is fixed, she again pastes in the user's logs. The new model no longer displays a bug in the system. Now that you've seen how Perfume can help with system understanding and debugging, go try it out for yourself.